Welcome to sunny Sedgwick. I'm David from Echo Wise Homes, and he is...
I'm Anthony from Outlier, and welcome to episode 2 of our Sedgwick hybrid home. We're going to dive into the framing details, the wrap, the air tightness details, and everything else in between. We're going to get straight to this one. Let's go. We're going to start from where we left last time, at the slab. We've got 2 bottom plates here, David.
Yep.
Why have we done this?
Yep. So you see with the 2 bottom plates, the very bottom one has been actually polyurethane down to the concrete slab, and that's just from an airtight perspective. And that will get connected to our WRB, so our building wrap on the outside with some polyurethane sealant. So the theory behind doing the 2 bottom plates is that when we're framing, it was the middle of winter on this project, and to get an airtight seal when you're framing over a 2-week period of in and out of showers and that sort of thing, that we can't guarantee that airtight seal with just the single bottom plate. Another thing is too, when we're building our wall frames, they're 140 mil wide, just a sheer weight and having to lift them onto our lines without smearing that polyurethane. So we find this first air seal plate works really well, that we can spend a nice dry day to polyurethane them down to the concrete slab, ensure get a nice connection, and then anywhere we've got the joints, polyurethane it. So then when we're framing, we're just focused on wall framing. We're not focusing on wall framing and air tightness, just so it's makes things a lot simple. I
mean, we've blower door tested this multiple times, and continually seen results under one air change an hour. Right. So we know that seal's working.
Yep.
Moving up from that, I noticed that there's a little bit of timber missing to what I'd conventionally see in a wall frame.
Yep.
So, I mean, firstly, I imagine that reduces thermal bridging, and if we add that up across the entire project, that's fairly significant.
Yep.
So what have you done here to be able to remove some of that timber from the frame here?
Yeah, so traditionally you'd see a block of timber underneath your window trimmer to support the window, and that can be a block that goes down that far or right down. But we have on this project, or the way we build, is we actually put a big batten screw all the way through here to structurally make that sound.
Yep.
So when I was an apprentice, I was always taught to build with more timber. More timber is better, structurally sound. And don't get me wrong, we've got to take structural integrity in consideration, but it's about the less timber you can build with, the more insulation you can have in your home and the better performing it is.
Yeah, I mean, for someone who came from a volume builder carpentry background, it actually haunted me the first time I went back to having to do 600 spacings and 600 centers on framing. But here we are. The more you know now that it reduces thermal bridging, the more on board you are with those outcomes. In this instance here, our framing is around a window that's just been recently installed, and I can see a sill pan here. Yep. So maybe we'll move on to that next, I think, and get you to explain that as well. So before we get to that sill pan, a few things caught my interest that I think we need to discuss first. Yep. So we have some pretty unique looking wall junctions here. Can I get you to explain, David, what is happening and the purpose and why we're doing this?
Yep. So the whole purpose of these noggins is it's less thermal bridging than what you traditionally see. So a few things. Homes are generally framed up at a 90 mil here in Australia, 90 mil stud walls. First of all, we're using a 140 wide stud wall, so an extra 50 mil bigger. So traditionally, we've got an internal wall running through here, and what traditionally you would see is a stud there to pick up plaster in that room, and a stud there that picks up plaster in this room. And then the walls get built and you have a stud there. So what happens is that your external part of the house gets wrapped, then insulated in here, there, but then this little pocket here gets left out and creates a cold spot in the middle of winter. So the way we've done it on these projects is that we remove these studs. Obviously this is internal wall, we'll have a stud there. That way insulation bats can get tucked in either side. So you've got more insulation, less thermal bridging because you've got one less stud, and these noggins are just been installed at plaster specifications to comply with fixing for plasterboard.
Yeah, that's fantastic. And your spacings of your studs are all at 600 to reduce thermal bridging as well?
Yep. So traditionally in Australia, majority of custom builders are doing their studs at 450 mil centres, but we're just increased them 600. Again, less timber, more insulation.
Yeah. I mean, the more insulation that we can fit in our walls, we have a better thermal performance outcome.
Yep.
If we move our attention to the very top here, we've got our standard top plate and then a ribbon plate, which is, again, pretty conventional to what we'd normally see in Australian construction practices, but just above that is something that is very, very different. This is a 17mm plywood strip, which is taped onto, or the external wrap, I should say, is taped onto that plywood strip. And then that allows us now to run a continuous bead of polyurethane on that plywood strip and adhere our plasterboard to it. Great thing about that depth or thickness of plywood is it's consistent to the thickness or the sizing of the ceiling batten. So we can keep a nice level and flat ceiling through. And in hipped roofs where we typically would install noggins at the ends of the trusses to pick up the ceiling battens running in a certain direction, we don't have to do that because we can, again, the reason for removing those noggins that would pick up the ceiling battens is to increase the insulation, reduce thermal bridging, and by doing this, we're able to achieve that. We also have the air tightness factor consider further to the thermal insulation factor. So that wrap, as we said, is taped off to that plywood strip. We now have plasterboard adhered and to that plywood strip, and now we have a continuous airtight layer moving throughout the entire home. Any of the, as we've spoken about prior videos, any of the penetrations in the airtight plasterboard layer are contained and airtight, but we'll go into that in more detail in future episodes. This is another advanced framing technique, often called a Californian corner, except you've taken this to another level here, David. Normally I'd see 3 stud arrangements, but I only see 2 here. I'm going to get you to run through that as well and what you've done. Yeah, so first of all I might just chat about what you'd traditionally see on a normal corner, a 3 stud corner, is that, so we've got a stud right here in the back corner, which is for cladding, a stud here which picks up plaster internally, and then traditionally you'd see another stud that goes back in there, which is sole purpose is just plasterboard. And as I explained with internal wall junctions, that traditionally that your house gets wrapped, insulators come in, insulate this pocket here, but then right in the back corner gets left out in the middle of winter, cold spot. So yeah, what we do here is we're done as Anthony explained, a Californian corner, which normally you'd see a stud on its flat and go back in there. But then that's a 140 stud, but then you take up 35mm of timber and compress your insulation. Obviously we all know that compressed insulation isn't good. So we just use offcuts of the plywood that we use for our top plate connection, and we just nail that into the studs, and that way we can get a R4 insulation back without compressing it too much right in that corner. Just about, again, just rethinking what we're doing and trying to build smarter. Yeah, well it is smarter. You've already had that material on site, you've had some leftovers, and you've been able to utilise that here in these framing junctions and have an even better performance outcome. Mate, would you mind explaining to everyone what's going on here with no internal walls in the home? Yeah. Surprisingly, you would think that everyone would notice that there's actually no internal walls, but it's not until you point it out. And then the first question you get is like, why? Well, what it's given us the ability to do is run our plasterboard sheets continuously through and then come in and install the internal walls. Now the plasterboard in a hybrid home is our airtight layer. So that's how we're able to achieve that continuous airtight layer. And it's also one of the things that do make this very unique. It's not traditionally seen in Australia, it's done quite successfully overseas. Now again, we've blower door tested this on numerous occasions and we've seen results of the same as Passive House at 0.6 air changes an hour. So moving forward, you've got these timber portals that's been put in the design. What's happening with that? I don't know, I'm going to start back in pre-construction, which is a service that David offers and is one of the really big things that I think has contributed to the outcome and success of this design and this build. So in design phase, Dave, myself, and our engineer that we work with, Andrew, were having some issues with trying to get enough structural bracing into this very open cathedral area. And originally we started off with timber trusses, and that meant then having to have a plywood diaphragm roof and a lot of other structural steel in the mix. But I think David and myself were talking and we realised that if we change those trusses to portal frames, we're able to remove the plywood diaphragm, we're able to get rid of the steelwork, and we actually think that it looks, much better aesthetically.
It's a pretty nice change in it to still have that same natural timber look in the home, whether it's trusses, but then obviously now these have a structural purpose and that sort of thing. But it's certainly looking very pleasing. It's amazing.
Now, these particular portal frames, the timbers come from the truss joint.
Yep.
Now they're a Tasmanian oak. Is that correct?
That's right. Yep. Tasbeam. Yep. They're all finger jointed Tasmanian oak timber, black powder coated plates.
Yeah, look, I think they're a 135 by 300-ish or something like that. Fairly substantial. We've got the beautiful exposed plate and bolt connections, which we've powder coated in black, and we think they're a massive feature of the home.
Yep.
It did require some forward thinking though for air tightness and insulation. So what have we done to achieve that? I think we can sort of see maybe on that side.
So as Anthony was saying, the home's got continuous plasterboard on the ceiling right through and along the walls, and that works really well when it's continuous. But as soon as you start breaking your plasterboard with stopping and starting, you're required to make sure you seal that with polyurethane. So here we just use strips of our wrap from outside. So that just goes from one side of the portal across to the other side, and that will get a bead of polyurethane down there, plasterboard fitted in there, and then the plaster is just trow that in there. So
and now you've already installed insulation in that cavity, so that's all been insulated.
Well, actually no, there's no cavity there because that's just a double structural stud there.
Fantastic.
And then this actual stud we could have twisted that around to go front to back, but it's been put on as flat that way. Again, we can tuck a insulation band in the back there.
Right up to that structural stud on the outside. Yeah, that's great. Yeah. And at the top of that, we've also got the plywood, so the plaster sheets will go in between these portal frames, and again, that continuous airtight seal right across.
That's it.
Now, we did have a little bit of thought towards the lighting fixtures that we used in this space. Given it is a cathedral ceiling, we don't have the space above that ceiling like we traditionally do to put an airtight container. So here we've done surface mounted or pendant style lighting, which then we can just seal with some polyurethane, seal up around the cable penetration through the plasterboard, and that will now be airtight as well.
Yeah.
Okay, so moving over here.
Yep.
This is a really nifty response. So we have a floor, a window that goes right down to the concrete floor. Now, to ensure we can keep that airtight and also mitigate bulk water egress, you've got a flashing folded up here. I might get you to walk through what you've done and how you're going to achieve that air tightness here, and stop water getting in the home through that window.
So there's obviously, as Anthony just mentioned, we've got two things we really focus on here. Is that bulk water control, stopping that from getting to the frame and then also into the concrete slab, and then obviously air tightness. So we have this flashing folded up. So this flashing will get tucked in underneath this building wrap. So that building wrap will go over the top of it. And then this flashing will get a bead of polyurethane underneath it, and then all polyurethane to the building wrap there. So that's focused on sealing up between the slab and our flashing. And then we will put a bead of polyurethane on the inside of our flashing, and the window will get installed, dropped on top of it, and that way we're controlling both that air and water.
Fantastic.
One flashing. Yeah.
We'll keep going because I want to talk about what's under that flashing, but we've got a better view over here.
Yep. So this one here is probably a good one for you to explain, Anthony. But the structural steel that's in there and the recess and that sort of thing.
I'll go down to walk through this. So we've got a rebate in the slab here, and that's due to the fact we're using a lift and slide door. So we wanted to try and keep the sill of that door down as low as possible so it doesn't create a tripping hazard as we move in and out of the home. And it also allows us to then control bulk water by having a back dam in the rebate of the slab, as well as then an ability to seal along that junction of the slab and the lift and slide door frame for air tightness. As we've got a 140 stud, we actually overhang the 140 off the slab 50 millimeters, which allows us to run our 50 millimeter XPS insulation board up and to be flush with the outside of the 140 stud framing. But to pick up the really heavy lift and slide doors or windows that go down to the ground, we need to install a bit of unequal angle. This is a 50 by 75, and it's just bolted into the side of the slab, and then we've got the 50 mil XPS insulation installed to the underface of that. So we've got that continuous insulation still, we've mitigated water, and we've also got our nice airtight seal.
And like on you guys specify to waterproof the recessed cavity here?
Yeah, I mean that's another really important factor as well. It's not just relying on an external flange like off the window or door as you traditionally see. There is actually not just a back dam but a continuous waterproofing membrane as well along that entire opening.
Yep.
And that returns up our WRB or our external wrap, so it's continuous.
And then so we also have some structural steel in the project, Anthony.
Yeah.
Which over in these corners here. So how do you mitigate throughout the design process for that to be a thermal bridge? Yeah,
so this is where the 140 stud really works in our favour again. It's allowed us to use 90mm steel wherever we can in the project and keep that flush as much as we can to the inside of the framing, which we can see here. And then on the outside, we're then able to install a 50mm XPS insulation board, which continuously, provides a continuous thermal break to the steelwork to the outside environment and the WRB.
Yep. And orientation of this project, like north is where?
Yeah, so we're basically, where we're standing behind us is due north. And that is the reason why we have these large openings in the wall here, because it's all going to be glazed.
Yep.
And that's just trying to get as much solar gain as we can right into the home. Now, I think you put a tape measure on the penetration from the sun the other day. What did we? Yeah,
so it was a couple of weeks after the winter solstice, and I think we had just under 8 metres of solar gain on the concrete slab, and obviously hitting that thermal mass, which obviously stores that heat over a period of time and that, so it's pretty impressive. Yeah. And what's your thoughts like with the blocking that out when it comes summertime and that?
Yeah, so during the design phase, we always do a pretty in-depth shading analysis. And in this occasion here, we do have a pergola structure that's going over the face.
Nice.
And that's going to basically shade all of the sun from entering into the home into the summer months and allow it to come through in all of those transitional months and all through winter to provide that free heating source into the home.
Yep. And obviously you add into the design and a good size eave on top and that sort of thing to block out the highlight window above it. Yep.
Yeah, that's right. It's not just these doors that we're talking about. We also have high set windows here, or clerestory windows, to really maximise that solar gain. And we've continued our weave over the top of those as well. And again, that's been optimised in the design process to adequately shade during the summer and provide that warmth in the winter.
All right, mate, would you mind chatting everyone what's going on with this building wrap and the importance of correct installation, building wrap and that sort of thing?
Yeah, so again, a big thing for us is, like, I guess we have brand utility, so we're not really, liking to use one particular product or not. We want to assess how that wrap performs to this exact climate, these exact conditions, and then, I guess utilise what's going to be best fit for that. In this case, we worked with Stuart Dawson from Thermalux, and he was able to advise us on this Trade Select product, which is great. It's vapor permeance and values were right where we needed them to be for this particular project.
Yep.
Now, a really important thing is taping the joints. This is probably one of the most significant things that is underrated in construction in the country at the moment. The wrap can be an air control layer, it can be a bulk water management layer, it covers all bases, vapor, you name it. But taping the joints is where it can fall short. So ensuring that every single overlap of your wrap is taped and sealed vertically, horizontally, and even furthermore, you can then return that back into your window openings in your framing and take those off. So now you've got that continuous protection.
Yep. I think that adds to the whole wrapping it back in here, adds to the whole bulk water management, that sort of thing. I know you always design these seal pans in your job. Would you mind explaining to people why you specify all these in your projects?
So for this, we can do more conventional practices to create what we call a back dam, which is this part of the sill pan here. And you can then use different materials to create slope and get that out, and still use tapes and make that all watertight. But for ease of construction, I'm really fond of this Dura Systems product, which basically is a CNC PVC sill pan, which has the built-in back dam, it's got the built-in slope, and it's also got the area here which you can pack off to get your window nice and level. That can then be taped along the front with a non-vapor permeable tape, and that'll allow any water that finds its way into these window openings, to then drain out the ventilated cavity system.
And when we're talking about water in in the windows that we're talking 40, 50, 60, potentially even 100 years down the track when, you know, things may potentially start to fail in the home, that we want our structural frame to always hold integrity. And, you know, that's where this whole Duracell system and back dam and, you know, continuing that wrap around there, you know, adds longevity to the home.
Yeah, I mean, it's no secret that the weakest point of any building fabric is the window and door penetrations in the exterior envelope.
Yep.
And, you know, this also allows any damage, if it was to occur to any of those windows, or even a retrospective upgrade to the windows for high performance, they can just be removed and then reinstated quite easily with these systems.
Yep.
So it's forward thinking for many generations to come.
Yep. So on this job, you were real important that we got a ventilated roof space and a ventilated roof cavity. Would you mind explaining, Anthony, what's the difference and why we've done this?
Okay, this is probably one of the best examples, side-by-side comparisons that we've ever had. So on the side here, where you can see the exposed trusses and you can see that heel that we've got on the truss there to really fit as much insulation as we can in, we leave a little gap at the top, pretty much the depth of the top quarter of the truss, so let's say around 90 to 100 millimetres. And we'll have that wrap continue up, which will then provide a wind shield against that ceiling insulation to stop that wind washing effect and the reduction of the performance of that insulation. But we then allow that little space above that to have continuous ventilation going through. So now we've got a lightweight cladding here on this project. The ventilation will be able to go up the exterior of this wrap, increasing the drying capacity of any moisture or condensation that does find its way into that space, but then continue up and into the roof space. So that whole roof space will be ventilated, and we'll have a ridge vent that allows continuous airflow out of that as well. So we have this airflow capacity, or this availability of airflow over the entire envelope of the home, through the roof space and out. On this side, however, is a different strategy.
Yep.
Now this is again due to the fact we have a cathedral ceiling in the home. When we have a cathedral ceiling, we've got that basically fully packed with insulation. There is no air cavity above the insulation in here. So what we've done to still have a continuous ventilation system is put a timber piece on top of our rafters, minimum 20 millimetres thick,
yep.
To allow airflow over the top of the wrap. And I should just clarify, the wrap here continues up the wall and over the rafters and purlins of that cathedral ceiling. And then we have a timber on top of that wrap, which then creates our airflow. And then we have our horizontal battens, which picks up the roof sheeting, allows the roof sheeting to be installed. So again, airflow can continue up the exterior
yep.
wrap, all the way over the top of the wrap on the roof, and keep that continuous airflow for the drying capacity
yep.
for any condensation that may find its way in there.
It truly is a good example of the two different ways to do roofs. So you've got your vented roof space. They're actually trying to keep that roof space in the middle of winter as cold as possible, or as much as possible the external temperature. And then with this is your more sort of you know, ventilated cavity system and that. So yeah.
Yeah, and I will just mention, I probably didn't touch on it, but the way we're trying to mitigate condensation underneath the roof sheets on that side is using an anti-con blanket.
That's
so
right.
we're putting insulation hard packed up underneath the roof sheet,
yep.
which then mitigates that condensation or dew point occurring on the underside of the roof sheet.
That's right.
And then on this side here, it will form on the underside of the roof sheet,
yep.
but we have that drying capacity that allows that to disperse down the ventilated cavity.
And the whole ventilated roof system just comes about from a cost perspective.
Yes.
This is definitely the premium option, but it comes at a cost, where this is, you know, what I'd pretty much call traditional sort of construction here in Australia, and it's a very cost-effective way to do it and that sort of thing. And so far it's proven to have good results for us.
Oh, it has. You know, we have sensors in other projects on this. We have no dew point or condensation issues in the ventilated roof space approach here. But I'm glad you touched on that, because I do want to just reinstate that, like, our approach to the hybrid home is to try to see how far we can push conventional construction, conventional materials, and methodology, which, you know, an insulated roof blanket is very common practice. And if we're able to achieve that high performance outcome still with that sort of system, that's what we're aiming to do here.
Yeah, and I think we're both very big on that, because I know, you know, previous jobs I've done things differently, and on this job I'm trying to do things differently again, just to a speed and cost perspective, to again, like, you know, push the boundaries and try and make it as much as possible as normal construction to get a well-performing home.